Hello everybody, so today I will talk about calculus. The topic today is about integration. So now I will show you the answer. The first one we need to use about trigonometric substitution. So we put about W equals to the square root of number 7 secant of t. If we do first the derivative, you will go about the square root of number 7 secant of t tan t dt. So we put this one going here and here. So we got about number 7 secant of t square multiply with the square root number 7 secant of t square minus number 7 ds, we change for the square root of number 7 secant of t tan t dt. So we have the square root of number 7, we put outside in here. This one we got about secant of t square minus number 1 dt. So this one we got about tan t square the square root of tan t square, you got about tan t. So we simplify tan t. We simplify tan t and the square root of number 7 and the secant of t with secant of t in here. So you got about 1 over 7 secant of t dt. So we got about 1 over 7 the integral 1 divided secant of t, you got about cosine t dt. So we got about 1 over 7 sine t plus c about t. That's it about this one. So we divide both sides with the square root of number 7 and we got about t equal to arc secant of w over the square root of number 7. So we put this one go in here. That is the answer for question number 1. Now let's go to question number 2. We use the same technique and we need to use about t equal to phi psi t, or sorry, phi psi u. So we got about dt equal to 5 cosine u du. So we put 5 sine u go in here and here. So you got about 125 sine u to the power of 3 over the square root, oh sorry, no square root, 25 minus, we put this one going here, you got about 25 sine u square to the power of 2. This one dt we change for 5 cosine u du. Now we have number 25 and number 25. We can do about factorization, and you got about 25 square 1 minus sine u square so we have number 5 and 125. You will got about 625 sine u to the power of 3 cosine u du. We simplify the number and you got about number 1, so that means this one they will cancel. Now the next one, one minus sine u square, you got about cosine u square. Because we have the power 2, you got about power 4. We simplify cosine u. About sine u to the power of 3, we can put about sine u square sine u over cosine u to the power of 3. About sine u square, we can change into 1 minus cosine u square sine u over cosine u to the power of 3. So in this situation, we can use about integration by substitution. So we put about z equal to cosine u dz. You got about negative sine u du. Because we don't have the negative in here, so we put the negative next to dz. So we got about cosine u we change for z. Cosine u to the power of 3 we change for z to the power of 3. Sine u du we change for negative dz. So this one 1 divided to z to the power of 3, you got about z to the power of negative number 3. This one you got about negative number 1 over z. And we got the final answer. About z, That's it about cosine u. About u, we need to go back to the first one. Here is about t equal to 5 sine u. We divide both sides with number 5, and we got about u equal to arc sine u t over 5. So we put this one go in here. And this one. Now let's go to the next one. We use the trigonometric substitution. So we will put about tan x equal to 2 sine t. If we do first derivative, you got about secant of x squared dx equal to 2 cosine t dt. So we have 4 minus tan x squared, we change for 2 sine t, so you got about 4 sine t squared to the power of 3 over 2. Secant of x squared dx, we change for 2 cosine t dt. We have number 4 and number 4. We can do about factorization. Four to the power of 3 over 2. You will got about number 8. 1 minus sine t squared, you got about cosine t squared. Cosine t squared, you will got about cosine t to the power of 3. We simplify cosine t, number 2 and number 8. And we got about 1 over 4. The integral of dt over cosine t squared. And this one you got about 1 over 4 tan t plus c. About t, that's it about this one. So we divide both sides with number 2, and we got about t equal to arc sine of 2 over tan x. So we put this one, we go in here. I made the mistake code, so that should be about tan x over 2. And that's it, the answer for the question number 3. Now let's go to number 4. This one we need to use about substitution. So we put about u equal to e to the power of z du. You got about e to the power of z dz. So we got about du over u squared plus au plus 7 to the power of 3 over 2. Now about this one, we got about du over u squared plus au. We need to have number 16. Why? A is about 2 and number 4. To do about a plus b everything to the power of 2, we need to have number 16. Number 16, that's about 4 to the power of 2. That means we need to minus number 16 plus 7 power 3 over 2. So we simplify. This one you got about u plus 4 everything to the power of 2 negative 16 plus 7. You will got about negative number 9 to the power of 3 over 2. So we need to use about integration by trigonometric substitution. So we put about u plus 4 equal to number 3, and we put about secant of z. If we do first derivative, we got about 3 secant of z tan z dz. This one we can put in here. So u plus 4 we change for 3 secant of z. We put this one with the power 2, and you got about 9 secant of z square minus number 9 to the power of 3 over 2. We have number 9. We can do about factorization, and we have the power 3 over 2. That should be about 27. This one we change for tan z square. And we got about 3 secant of z tan z dz. This one you got about 27 tan z to the power of 3. We simplify tan z and number 3 in here. So you got about 1 over 9 secant of z over tan z square secant of z, that's about 1 over cosine z. Tan z, that's about sine z over cosine z. So we had the power 2. And we got about 1 over cosine z over sine z square over cosine z square. So we put cosine z square on numerator and then we simplify with cosine z, and we got about 1 over 9 the integral of cosine z over sine z square dz. This one we can use about integration by substitution. So we will about sine z equals to t, or no, and we do first the derivative of this one. So we got about 1 over 9 the integral of sine z square, you got about t square. This one you got about dt. So we got about negative 1 over 9t plus c. So about t, that's about sine z. About z, that should be about this one. So we divide both sides with number 3, and we got about z equal to arc secant of u plus 4 over 3. So we put this one go in here. So this one we got about u, that's about e to the power of z. And that's the final answer. Now let's go to the question number 5. We have negative number 6. That means we have number 2 and negative number 3. So we can put about theta square minus 6 theta. To get this one a minus b, so we need to have number 9 in here. That means we need to minus number 9, and we plus 18 to the power of 3 over 2. So this one we got about d theta over theta square minus 6 theta plus 9. We can change into theta minus number 3, everything to the power of 2. This one you got about positive number 9. So we need to use about trigonometric substitution. So we put about theta minus number 3 equal to 3 tan t, d theta equal to 3 secant of t squared dt. So we put this one go in here. So you got about 9 tan t to the power of 2 d theta. We change for this one. So we can do about factorization with number 9. So you got about 9 to the power of 3 over 2, and you got about 27 tan t squared plus 1 to the power of 3 over 2. This one we need to change into secant of t squared. This one we got about secant of t to the power of 3. Number 3 simplified with number 27, you got about 1 over 9. And we got about secant of t squared. We simplify secant of t squared, and we got about 1 over secant of t. So this one you got about cosine t, because 1 divide 1 over cosine t, you got about cosine t. And we got about 1 over 9 sin t plus c. About t in here, that's e about this one. So we divide both sides with number 3, and we got about t equals to r tan. And we have theta minus 3 over 3. So we put this one go in here. Now let's go to the last one. We need to use about substitution. So we put about u equal to ln h, du equal to dh over h. So this one you got about u to the power of 3. This one you got about the square root of u square minus number 4. dh over h you change for du. Next, we need to use about trigonometric substitution. So we put about u equal to 2 secant of t du. We got about 2 secant of t tan t dt. About u, we put in here, and we got about 8 secant of t to the power of 3 over the square root. We put u secant of t go in here, so you got about 4 secant of t squared minus number 4, and we got about dt. Sorry, about du, we change for this one. So we put number 4 outside the square root, you got about number 2. This one you got about tan t squared. The square root of tan t squared, you got about tan t. We simplify number 2 and tan t, and we got about 8 secant of t to the power of 4 dt. So we know that secant of t to the power of 4, we can put about secant of t squared, secant of t squared dt. Secant of t squared, we can put about tan t squared plus 1. So we need to use about substitution. So we put about z equals to tan t, dz equals to secant of t squared dt. So this means we got about z squared plus 1 dz. So we got about z to the power of 3 over 3 plus z about z, that's about tan t. About tan t, we need to go to this one, so we divide both sides with number 2. We got about a secant u over 2, so we put this one go in here. About u, that's about ln s. That's it the end. Thank you for watching.